Hello Internet. Today we're going to be taking a look at sort of running Git locally. So Git is a source control engine that is distributed. It's a distributed source control system. And so what that means is, well, there's two parts to it. Source control, meaning it can control your source. Think of it as a way to keep track of how your code or your project has changed over time. The distributed part means that it is not hosted in one place. There's not a server where all of your code sits and then you go to that server to figure out what's going on. It's distributed, meaning you can have a copy and somebody else can have a copy, and that server over there can have a copy, and GitHub can have a copy, and Visual Studio Online can have a copy, and they can all sync up between one another. So they're all part of the same source code. It's just all distributed between a number of people. So there's no single source for that. The advantage of all of that is because it's distributed, you can have the entire source code, all of the branches, everything, locally on your machine, which means it's really handy if you want to work on it, say, at home, or if you want to move it somewhere else, or things like that. It makes it really easy to kind of take something and move it somewhere, or take part of something and put it somewhere else. So that's sort of the point. We're going to be specifically looking at using this locally. So we're not going to be syncing this up online. If you've seen GitHub or Visual Studio Online, we're not going to be using any of those. We're going to be doing this all locally. It's all going to be on one machine, my machine. And so the idea is just, how can you use this locally and what are the advantages of that? So this is just going to be the basics, but it should be enough to kind of get you started. So right now I have just Git example. It's just a folder on my machine that is completely empty. So you can see all the files in my folder over here. This is going to be sort of a solution explorer or whatever you want to call it. What I'm going to need is to create a project, which means I need to actually select that. And let's do a new terminal window. So this is going to just open a new terminal down there. And let's just initialize something. So let's do .NET new web API. And so there's two ways you can start. The first command we're going to use is git init. That's actually going to initialize Git in our current directory. So you want to do this in the root directory of whatever you're putting under source control. And so in this example, the reason I just did .NET new is it created a whole new .NET web API application that we can just use. And so this way I don't need to create a bunch of files. But this gives a good example of if we already have a project, say it's something you've been working on for a while and it's getting to the point where you're like, I want to put this under source control, or you start working on something and you're like, I should have put that under source control. There's no problem there. If I run git init, it'll work the same whether I run it on an empty folder or something new. So git init is going to initialize a new repository. I have PoshGit, which is a PowerShell extension. And so you're going to see this here. What this means is there's 7 new changes. There's no removals. Nothing's been deleted. And I believe that's modified. I might be wrong there. And then master is going to be the branch. By default, Git creates a repository with a single branch. I shouldn't be pulling up Unity over that. But so master is a branch. What's the best way to describe a branch? A branch is a type of your code. I think that's the best way to put it. Imagine you are working on something and you need to make a change, for example. In Git, the general way of doing that is creating a branch and then pulling that branch back in once that code is done. The advantage of that is, think of a branch like a separate feature. It allows you to implement your feature on top of a stable branch of code or a stable version of code, and then pull it back into the current latest stable version of code. So it's kind of, if you see a Git tree, it'll kind of look like you'll have a middle line. That's sort of your master branch. And then as you develop things, let's say we want to change how our response code is. In this case, we have, say, controllers. It's got a values thing. Let's say we want to add value 3. So that gets returned as well. We could create a branch that says The branch names don't really matter. They can be named however you want. A lot of people will have different ways of doing that. If we just want to say adding value 3, we can do that, and that will create a branch based off of wherever we branched off of. So the source code is going to be the same across those branches. There's the idea of a Git Head, which is sort of where you are in the repository. And so it's just, think of it like a sequential dot map. You're connecting these points, and each of those points is a commit in code. It's a save point. Think of it like a path system. If you are walking in a path or you're in a dungeon in some game, there's going to be checkpoints that you reach. In source control, those are your commits. Your commits are your checkpoints. And those are just, I reached a point in my code that I want to save my progress. And so you can do that. But the cool thing with Git compared to, say, that game is you can go in different directions. So you can reach a point and then say, I want to continue down this path, but there's this other path over here that I want to go down as well. And that kind of gives you that option. That's sort of what a branch is. It's literally going in 2 separate paths. But the cool thing about Git is at the end, once you've finished whatever path that other detour was, you can merge back in and get the changes, everything you found, all the loot, back onto your main path. So we're on master. It's just the name. And if I do a Git Status, we're going to see a whole bunch of things got changed. There is a number of folders that are listed here. And we have these app settings. That's just normal stuff. Pretty much all of this is stuff that we actually want. But there's one thing we don't, which is going to be this object folder. I don't really want to include that. So what I want to do is ignore certain files. And so what we're going to do is create a Dot Git Ignore. The dot is really important. If you just type Git Ignore, it's not going to work. This is sort of a syntax for hidden files on Linux. Require assets to build and nope, not now. And so this is just a list of files that you don't want to include in Git. And you can do folders and whatever else. So if I put object there, you can see over on the left there, Visual Studio Code has grayed out object, which means it's no longer being considered. If I do a Git Status, that's not how you type that. Git Status, we'll see it's no longer there. Our Git Ignore got added, but that object, those object files, they're not there anymore. And so this way you can avoid committing things that you don't necessarily want there. Some examples of that would be like secrets. So if you have passwords for accessing specific APIs or something like that, you don't want those in source control because anybody that gets access to your source control suddenly has access to all your passwords. So that's something to keep in mind. Don't upload your passwords to source control. Don't upload anything you want to be private to source control because it's just going to become a mess. Maybe you want to go open source one day and somebody just looks in your history and is like, oh, I'll take that. Just don't do it. There's other ways to do that. We may get into those later, but totally off track for that. We don't really need to worry about that. The next step is we are going to add these files. So we created this Git repo, but there's nothing there. You can see all of these changes are red. They haven't been added. There's no, they haven't really done anything. They're there, but we're not tracking the changes for them. We're not really doing anything for them. So what we need to do is add all of them. We can do this the boring way, which is just this way. So I can do like git add, git ignore, git add controllers. You can see it's changed to +1, which means we've staged one add. So staged is going to be all of the things that we have scheduled to be committed. And I will get to that next. Yeah, we definitely can't just get our CS_proj file. There we go. There's easier ways to do this. And apparently I am bad at spelling. Also, autocomplete is a handy feature. But anyway, We can add these. There's other ways. I think you can do just git add star. Done. And that all works. There's a bunch of ways you can do this. You don't even necessarily need to do the add if you really don't want to. But this gives you a way to sort of specify the files you want to actually send up. Otherwise, any tracked file can be committed. So you'll see all of those files over there turned green. That means they are all staged. We've got those there. And if I do a git status now, they're all going to be green. And so the changes to be committed are right there. And we can see we have all these new files. So I want to actually commit those. So if I do git commit, if I just type git commit, it will commit the files. But depending on your text editor, I can actually try that. We're going to get this. This is kind of gross. This is just a text editor. The idea here is every commit has a message attached to it. And the idea is it's sort of to give you a context of what you were doing when you committed this code. So this would be like initial project commit. And so we can just type that. This is Vim. I didn't even know I had Vim installed. Okay, we're in Vim. So if you've never used Vim, I'll get back to the normal thing. This is what it would look like. I wasn't aware this was the thing. But if you hit I starts insertion. I'm not a Vim expert by any means, but it's the basics. So I is going to be insert. If you start doing just typing like I had started doing, I had meant to type insert, which is why I did I, and then you just saw the N. But if I do insert or initial project commit, we're done. This is all we need. This file is created by Git when you do a git commit. It's just a temporary file. And the idea here is you write your commit message. All of the things with the hash, like it says, are going to be ignored. And so we're just writing out what we actually want to commit. If I hit escape, we get back to our basic thing. And then I want to do :WQ, which is write and quit. So that's going to write to this file and then quit out. And so we committed our initial project commit and added those 7 files. If you don't want to do that, because Vim is hard, there's a whole slew of jokes about quitting Vim, and for good reason. If you're not familiar with it, it gets really confusing really fast. The easiest way to do a git commit is just to do -m and then in quotes the message you want to commit. If you don't do quotes, just command line things, it's only going to take the first word, and then after that space. Those are all treated as additional arguments, and you're going to get into a whole bunch of trouble. Anyway, oops, got my nice Windows beep on. Let's see here. Now that we have that, we've committed our project. We can pretty much change anything we want. And the cool thing is, if we ever screw something up, say I go crazy and break everything, we can revert that. Ideally, your master branch, this isn't the same for every project, but ideally you would have some branch in your project that is stable code, that is something that you can actually release. And so in this case, we'll say master is that. What I want to do then is do git branch. Less familiar with these, but we're going to do a new branch. Git branch. And we're just going to call this, what do we want to call it? We need a new branch name. They can't have spaces. I don't think they can have spaces. They shouldn't have spaces. We're just going to call this, well, change value responses. And so this created a branch. You can see though, it still says we're on the master branch. And if I do git status, we're still on the master branch. If you don't have posh git status is a nice way to kind of catch up with what's going on in your repo. You won't necessarily have something like this that's sane. So just git status and it will tell you the files that have changed, what branch you're on, and things like that. So we have that. We've created the branch. The branch exists. But to get to it, we need to check out that branch. So you can have as many branches as you want, and they can be in whatever state you want them to be in. Branches are isolated from one another, so if I make changes to this new master branch, those changes aren't going to affect the new branch I created, and vice versa. So if I check out the change values response, change value responses, we have now switched to the change value responses thing. And you can see Visual Studio Code recognized that, PoshGit recognized that. We used capitals instead of lowercase because I'm good at my job. And there we go. So now we're on this new branch. So what I want to do is exactly what I said earlier. Let's change this value Git to return 3 values. And so value 1, value 2, and value 3 get returned when you call API/values. So that's our change. If I go here, we'll do a Git Status. You can see we've modified that file and it's being detected there. You can see the little squiggle. And so let's add that change. Git add, In most cases, it's best to be explicit about what you're adding. The star works in most cases, but you can get yourself in trouble like committing secrets pretty easily. So especially when you're getting started, I would recommend staying to being explicit, especially if you're working in a smaller project. This is way easier. And so there we go. We have now committed that or added that. We need to commit it. So git commit -m. Making sure I'm not going over the camera over here. And we'll just say add value 3 to response. And so that is our commit. We did it the easy way. We don't need to go into Vim or anything like that. And you can see we added that. There was one file change that had that insert. There we go. And so that's that. This is actually going to tell us the lines, I believe. I believe that's lines. We only changed one, but you can actually do all sorts of fun stuff with this. Git has a lot of tools for you. We're not going to get into them here, like merges get kind of hectic. But anyway, we're here. We have this value 3. I want to run this. So let's do .NET run. I probably need to build this first. So this might not work. Yeah, let's build this first. .NET build, and then we'll run it. So this is going to restore everything, get our ASP.NET project set up. Let's do .NET run. There we go. And you can see we have some changes. We added something to the bin folder, and that's not ignored. So that might be something we want to ignore. Uh-oh. Address already in use. My bad, I have an old project running. Microsoft released a new WebAssembly project that I was playing around with, and it was running on the same port. This should fix that. So it's dead now. There we go. It's now listening on port 5000. So I should be able to open up Postman like this and go to localhost :5000 and hit API/values. And so if I do a git on this, you can see that's going to be super small. That is search. Well, that's unfortunate. So we have 3 values here. We have value 1, value 2, and value 3. If I go back to Git, I don't need to change anything to get back to that. We can shut down that application for now. Let's do a revert, or not really a revert, sorry. Let's just check out master. So we're going back to our master branch. You can see our source code already changed. Value 3 doesn't exist anymore. And you can go back and forth as much as you want. If I do, say, .NET run now, obviously, we're not going to get value 3 as a response anymore. So if I just run the same command again, you can see our change worked. So effectively, we have 2 versions of our code, one with and one without that change. And so we can do the same thing. I can add, say, bin to our Git Ignore. We'll stop that. Do a Git commit or Git add dot Git Ignore. Git commit ignore builds in the bin folder. There we go. And so then we've committed that. Now That change is there. We have a different change in our change value responses thing, and you can kind of see how this is going. That's sort of the idea here. The final thing, the one that I have never actually used from this command line, which I'm going to do now and probably regret in like a minute, I want to merge my change for change value responses into my master branch. So this is sort of that bringing the whole thing back, bringing your loot from the end of that path down the dungeon that you didn't necessarily need to go down, that side quest. This is going to bring that back to your main path. So there's Git Merge, and I don't know what this does, so I'm just going to do -help. Okay, it wants to open a web browser. That's interesting. Okay. People always use either --help or -h, and for some reason this one Git doesn't do both. Some do, some don't. So, what's the syntax? Options commit. So I've never actually done this from the command line, but worst case, when you do a merge, it actually is just another commit. If I screw it up with source control, you can go back in history to a previous version without too much problem. So, Git merge, I believe I'm on master and I want to take our values thing. What did we call it? Change values responses. No E or S on the value. There we go. Merge made by recursive strategy. You can see we merged this in, and so we didn't have any conflicts, and so now our master branch has that value 3, and that new change was already made to our project. So Git Status, we're there, we're still on master, everything's good, but now that change that we made over on that other branch got brought back. So this is really handy if you have a team, because then your team can have multiple things going on at the same time on different branches, and then they can bring that back into the main code once it is actually working. So you don't have people committing to the same place. Say you're using Subversion, that's pretty standard, I guess. If you're committing to the same branch or the same thing, branching is not the same in Subversion, it's just a little bit more difficult. And so a lot of people will just commit to the same repository. The side effect of that is then everybody is kind of putting their development codes sort of into your main repository, and that gets a little messy. So this just goes around that completely. It makes it really easy to get around it. And so this is sort of a way to run Git locally and kind of get some value out of it without necessarily having to get this up to like GitHub or something. Even if you're not planning on doing open source or working with a team or something, this can be really handy because it gives you that way to sort of synchronize everything and kind of, maybe you want to play around with your project, but you don't want to break it. Just create a branch, build your experimental feature, and if it broke, oh well, just revert back and delete the branch. Or if it did work, then cool, bring it back in and you're good. And so that kind of gives you that freedom. So that's that. Other than that, the cool thing is pushing this up to like GitHub is not that hard. And since it's a distributed thing, all of the status of everything that I've done, all of those commits will stay the same when I go up to Git or GitHub or Visual Studio Online or any of those other online source control things. It just works. So that is sort of the basics of local Git. It's not too complicated. There's a lot of tools. Visual Studio Code has an entire source control thing. Everything that I did can be done from this little window over here. And it's a little bit faster. You don't need to muck around as much. And if you run into like merge conflicts, they can be a little bit of a pain when dealing with them on a terminal compared to in a tool. So depending on what you're looking at, you can do either one. If you're learning, I would recommend starting with the terminal because it doesn't hide any of the steps. And some of these tools can. So try to learn it from the start and then realize that just pick up the tool afterwards. Know what's going on and then use a tool. So that's that. I'll leave it here. If you guys have suggestions for me or ideas for things we can cover in the future, let me know. If you're looking for more, I have a whole bunch of videos, so consider subscribing, or if you like this, give it a like, or if you didn't like it, then don't give it a like. We have a Discord channel. You can come check that out. There's a link in the description. We talk about code, a lot of Unity stuff, and just general projects and stuff. So feel free to come join that. It's a public thing. So yeah, I'll leave it here, and I will see you guys next time. So till then, see you, Internet.